Section 9.1 sequences. This is the chapter of series. You saw earlier or last week that roughly 25% of the questions on the AP test are in this one topic. Well, not sequences specifically, but series. Okay, and sequences is part of series. All right, so let's just look at sequences. So in this section, we're going to list the terms of a sequence, which is really easy. Determine whether a sequence converges or diverges. And so that's really basically taking a limit and write a formula for the nth term of a sequence. We're not going to do too much of that. In fact, I don't know if we're going to do any of that. We are going to use properties of monotonic sequences and bounded sequences. That is relatively important. So basically, 3 of the 4 bullets we're going to concentrate on. All right, what is a sequence? A sequence is a function whose domain is the set of positive integers. Right? It's positive integers. So this is a discrete set of numbers. Right? Usually functions are continuous. You can just kind of. But if you were to plot a sequence, it'd be a bunch of dots. Right? So it's a discrete set of numbers. Although the sequences are functions, we use different notation to represent them. To distinguish between a sequence and a function, we use a different notation. Usually with functions, we use this would be like a parentheses 1, but this is a sequence, so we use subscript, a sub 1, a sub 2, yada, yada, yada. All right. So this is the notation, right? A sub n. And this is the actual formula for a sub n, 3 plus negative 1 to the n. So we're going to find some numbers or substitute. So I'm not saying it correctly. A sub 1, just plug in 1 for n. So 3 plus negative 1 to the first, 2, right? Plug in 2 and you get 4. Plug in 3, you get 2. Plug in 4, you go back to 4, right? So all we're doing, if we want the first term of the sequence, we substitute 1 and we use the formula to get the value. If we want the second term, we plug it in. Now, the difference on some of these, sometimes they're not going to start at n equals 1. They may start somewhere else. But generally speaking, we're going to have them start at 1. All right, so here's another one, b sub n. Again, all we're doing is substituting numbers. So I substitute 1. So it's 1 minus 2 times 1, which ends up being negative 1. 1 minus 2 times 2, which ends up being negative 2/3, negative 3/5, negative 4/7. Now, I did not claim that these will all be integers as values. Okay, they're just discrete, meaning there's a distance between b sub 1 and b sub 2. There's a distance. In this case, there's a distance of 1/3, right? So they're discrete members, but that doesn't mean they're all going to be integers. All right, and there's one more, I think. All right, we're going to plug in n. So n equals 1, so it's 1 squared. 2 to the 1 minus 1 becomes 1. 2 squared over 2 squared minus 1. 4/3. This time it's 3 squared. 2 to the 3rd minus 1. Yada, yada, yada. All right. That's what that is. Okay. The fourth example, the terms of the recursively defined sequence. So this is a recursive definition. So if in the recursive definition, they have to give you a big initial value and then the recursive part. So the d sub 1 equals 25 is the beginning value, and this is the recursive definition or the recursive step. Right? D sub n plus 1, that means the next term is dependent on the previous term. All right, so here you take this term, 25, and then you subtract 5. So D2 is D1, which is 25, minus 5 equals 20. So this is the first one where it's defined weirdly, right? Even though this one is probably easy to define the other way. But this is just an example of how to recursively define a sequence. And this is actually a pretty popular way to define a sequence. I mean, we're still going to use regular formulas most of the time. All right. So d sub 3 equals d sub 2, which was 20, and then subtract 5, and d sub 4. All right, so this one's going down by 5 every time. You could probably figure out a linear formula for this. Part 2. Well, this is the end of part 1. It turned out to be pretty short. This was just an introduction to sequences. So this video seems short, and well, it is, but the other parts, I forget. Next part, we're going to discuss how to take the limit of a sequence. We're taking the limit of a sequence. That's where we're going to find out about convergence and divergence of a sequence. All All right, see you then.